Next, we want to talk about what is called a probability distribution function, or sometimes they're called a probability density function, which is just a function or an equation that's going to assume the probability of each value of a random variable. And it could be a discrete or continuous random variable. So these probability distribution functions have two properties. First of all, your probability, and we denoted this by p parentheses x, so that's the value of the function p at x. It's not multiplication. So p of x is between 0 and 1. So all your probabilities have to be positive. You can't have a negative probability, and they have to be less than 1. Because 1 is 100%, you can't have a probability of more than 100%. And then secondly, if you sum up all your probabilities over all x values in the sample space, you should get 1. So in other words, the total probability of anything happening is 1 or 100%. So let's verify an example here. So we're given a function p of x is 2x minus 1 over 10 if x is 1, 2, or 3. And we want to know, is that a probability function? Well, we got to check these two properties. So let's first list out the values of our probability function here. So this is x versus p of x. And our x values here could be just 1, 2, or 3. So they're giving us the domain. And if you plug a 1 in here, so 2 times 1 minus 1 is 1/10. And then plug a 2 in here. 2 times 2 is 4, minus 1, 3, 3/10. And then plug a 3 in. So 2 times 3 is 6, minus 1, 5/10. So we can see that condition number 1, 0 is less than equal to the probability of x is less than equal 1. That one holds. All these probabilities are between 0 and 1. And then the second condition, we got to check that, is the sum of the probabilities equal to 100%. So let's add these up here. So we total these. And you can use decimal or fraction, either's fine. So 1/10 and 3/10 is 4/10, and 5, that's 9/10, which is 0.9. And that is not equal to 1. So this one fails. So no, it is not a probability function. Second condition fails. So if either one of those fail, if right off if you got a negative probability, it's like one of these numbers was negative, you know it can't be a probability function. Can't have a negative probability. So, and again, this p parentheses x, that's our probability function, which is the rule that determines the probability of each value of our random variable. So usually it can be given by an equation, or sometimes you specify the experiment and you can determine these values from, say, a tree diagram or drawing out the sample space in an outcome table.